Welcome. This is Santiago Bouzas. I am a director of product management at Enea, and I am delighted to be joined today by Stefan Terrell. Stefan is a chief analyst at Light Counting, and he has recently published a report on 5G capacity and load balancing and why the mobile telecom industry needs to reconsider this function in the network. So welcome, Stefan. And to kick things off, in your report, you describe the changes in mobile networks in terms of traffic growth and how these higher volumes of traffic impose new challenges to scale up packet core network services, which have been using the very same load balancer technologies for the last 20 or even 25 years. Could you please let us know more about these changes and why they are happening?
Yes, thank you very much, Santi, for having me here. Very delighted. So yeah, things are moving very well in mobile networks, and we see traffic growth everywhere in the world because consumers are addicted to some extent to mobile applications. And as a result, mobile operators are filling up their 4G networks very quickly. Some are reaching exhaustion, actually, and they are also rolling out the 5G networks. What we also see is the 5G rollout is much faster than what we have seen for 4G LTE just a decade ago. So yes, traffic growth remains unabated across all regions. In the report, we show a few data points coming from Tier 1 communication service providers, CSP, / mobile network operators. And Asia Pacific is in the driver's seat when it comes to average throughput served in gigabit per second, followed by the Americas. But the other part of the story is if you look at where we are so far, almost at the end of March, we already have 3/4 of the global traffic is at 3/4 of where we were the last year for the full year. So this is just remarkable to see at how fast the traffic is growing, and it's totally unstoppable. And let's not forget that this is IP traffic. And that means, Mr. MNO or CSP, you've got a situation to manage with your load balancer to ensure a smooth user experience. And literally, the question is, how do you manage all that vast amount of traffic generated by the user's concurrent request to access the content and other applications? And we think the traditional load balancer cannot fit the bill.
So that's very, very insightful, Stefan. As you say, and we have witnessed this as well, mobile operators have been dealing with exponential traffic growth year over year. But more interestingly, you mentioned in the report that the traditional load balancer and ADC architectures that can be deployed either as physical appliances or more recently as virtual machines, they will no longer be economically viable for packet core applications. And in fact, you specifically call out in the report that they are not fit for purpose. So could you help us understand what are the specific challenges that traditional solutions face?
Yeah, absolutely, Santi. Yeah, if you look at the load balancer, the role is to efficiently distribute incoming traffic across multiple servers as applications scale. And as 5G core networks are designed with cloud-native functions, the current load balancers need to evolve and somewhat morph into a virtual network functions, VNF, that we have been talking about for more than a decade now. And think about the cost of sticking with the current boxes. This is a big deal because you keep piling up load balancer hardware in a 5G cloud environment. Does it make sense? I don't think so, because it's not only piling up the boxes, but you also miss the programmability aspect of the equation. 5G networks are fully programmable. So then think about the cost, actually, of acquiring the new hardware and the cost of operating, maintaining that hardware, all the cost of operation and maintenance associated to this piece of hardware. The next part of the cost is also the recurring license fees. And finally, if you want to maintain a traditional load balancer infrastructure over 3 to 5 years, because you're going to have to do it, it can cost more than introducing a new appliance or service. So the bottom line is adding boxes to cope with unstoppable traffic growth doesn't scale. Only the virtual load balancer can scale in this fast-moving environment.
So that makes sense. And when looking at these challenges and when taking into account all these limitations that you have outlined, what is your view on the new breed of virtual and cloud native load balancers that you talk about in the report? And more specifically, how do they help operators scale services horizontally, which is, as you rightly mentioned, it is essential for the telco cloud? And how can they also warranty session flow or even root stickiness while at the same time remain stateless?
Sure, Santi. Well, I think the most important aspect of a virtual load balancer is the fact that it is stateless. So let me explain. Traditional load balancer appliances are stateful. That means the information about a session has to be saved on the server. So think about it. This is very challenging when you have to scale in this fast-moving environment that we just described. The virtual load balancer is stateless. So this is the opposite. And that means it's fully virtualized, software-based, and distributes traffic across multiple application servers based on configurable load, availability, and policy. As a result, it provides a carrier-grade horizontal scalability to address the communication service providers, mobile network operators, network service demands to scale up 5G environments. And that can handle stickiness without having to synchronize state across instances. So what do we mean here is that stickiness can be configured per user, session, application, and data flow. All packets generated by the same user in session, application, or flow can be routed to the same application server. So that's a big plus. And if the application server becomes unresponsive, the system automatically determines a new endpoint to sell all incoming packets. This makes the virtual load balancer entirely stateless, as already mentioned, and that eliminates performance constraints and other state synchronization issues between instances. So this is what we mean by carrier-grade scalability. And of course, the last piece, the icing on the cake, is basically the virtual load balancer offers great flexible network insertion options. It can just be deployed as a VNF, virtual network function, on VMware or OpenStack. And soon, stay tuned, ladies and gentlemen, it's coming in containers. So that's going to be the big news by the end of this year.
So based on your detailed analysis, what would be the key takeaways and recommendations that the mobile operators would need to consider?
Sure, Sandy. Yes, I mean, in conclusion, mobile network operators or communication service providers, they need to embrace the cloud-native 5G world and move away from the traditional way of building box-based network functions to virtual and containerized network functions. This is the new age. This is a new world, the 5G world, that brings unseen programmability, agility, and scalability. Load balancers are no exception. Everything is moving virtual, as everything is moving into containers. So load balancers are going virtual, and their upcoming containerized versions will likely emerge, we think, by the end of this year. So as I said before, stay tuned for the next virtual load balancer episode that will be containerized load balancer.
Many thanks, Stefan. This has been very, very helpful. I would just like to remind you that the 5G capacity and load balancing report authored by Stefan Terhal and released by Light Counting can be downloaded through the link in the description. Thank you very much for your attention.
Thank you, Santi.
Thank you, Stefan.